Then looking at composites, we see the 787, A350 XWB, 50% composites by weight on the structure. The nose and the fuselage, the wings, the tails, they're all black these days. And why is this? Traffic is increasing, air traffic, all the time. The projections today are still, in the next 20 years, travel will double, unless, of course, we are slowed down by the climate change situation. This graph, it's a bit difficult to read, but at the top, there is a contribution of aerospace, which is just a few percent to the CO2 emissions, but it is becoming bigger percentage-wise. And this is a graph of some years ago of Airbus showing that even though the amount of miles being flown by people is increasing all the time, the jet fuel demand, that's the green line, is more or less horizontal. It's constant. And there's a reason for this, and the reason is the engines. The engines are becoming ever more efficient and larger. And here's the engines for the Neo, for example. So very, very efficient engines. And what does this mean? So if you have these efficient engines, the weight of the engine will tend to increase. Also, the wing will have to be reinforced to compensate for this. You'll be able to carry less fuel, and you'll reduce your range of your aircraft. So even though the engines are the big increase in performance, there is a drawback, and we need to compensate. And one of the ways to compensate is to reduce the weight of the rest of the aircraft. So if we look at different materials, we have density comparison. Water for reference, reference number 1. Then steel, 7.8, heavy material used in landing gears. Titanium, 4.7, used in engines, but also in combination with carbon products on the newer aircraft. Then we have aluminum, 2.7, glass composite, 1.9, and then carbon composite, 1.5. So it's a very low weight material. And then if we look at the strength divided by weight, we look at specific strength, we really see why the carbon fiber reinforced materials excel. Now most of you are probably aware of this, of carbon being a good fiber. And we have the composites. Composites are a load-carrying fiber and a matrix, polymeric material holding the fibers together. And the benefits of composites, so reduced fuel consumption and CO2 emissions, but also less corrosion and fatigue than for traditional materials like aluminum. So the major overhaul is at a much larger interval, roughly double the interval than it was before. And there is more comfort in the fuselage. You have a higher pressure, you have a higher moisture content, so for the passengers, it is a more positive experience, and larger windows as well. So to summarize, the aerospace original equipment manufacturers, they have several targets. And an important one these days is to reduce cost, to keep cost of flying feasible. At the same time, we do want to reduce weight. Everybody's talking about cost, but certainly if we want to reduce the CO2 emissions, we will have to reduce weight. And the problem often is with composites that these two requirements are conflicting. If you reduce cost, you increase weight. If you reduce weight, you increase cost. And the challenge is, can we find technologies, designs, where we can reduce both preferably? And that's a challenge. This aircraft, it's a Gulfstream 5 aircraft, developed many years ago in the 1990s, so it's not new. But at the time, we were developing a tail for this aircraft and the floor panels. The tail was largely in metal. The floors were in composite. And one of our engineers had an idea to reduce the cost of this tail, and it was specifically about the rear end, the trailing edge of the rudder on this tail. And he had an idea to fold a thermoplastic material instead of laminating it and putting it in an autoclave like we used to do, but to take a sheet of thermoplastic and to fold it into a product. And he started with a lighter behind his desk, just folding, playing around. And then my boss took it to Gulfstream, showed it to Gulfstream, and they liked it, and it became a real product. We're gonna heat this material and show it's safe. It doesn't really smoke and burn, but it'll get soft in the middle. And when it gets soft, I'm gonna bend it, and I'm basically gonna simulate a production step that we do in our factory. It takes some time. There it is, it's getting soft. So, there, and then it cools down. And when it's cold again, more or less cold, it's solid and stiff again. And this symbolizes the trailing edge of a rudder on a Gulfstream aircraft, which we make in a 7-foot length with a machine, but it's basically the same idea. So simple manufacturing. So thermoplastic polymers differ from thermosets in the fact that you can soften them with heat, shape them, and then cool down again. PEI is a polymer that's very suited for interiors of aircraft. So galleys, for example, luggage bins, very good flammability properties, very good strength. The only drawback of this particular polymer that you used in the specimen is that the solvent resistance is very low. So if you have very aggressive chemicals, you will damage the polymer. You might not see it, but it will crack at the surface. But what we do in the factory is this. It's a Toray product, sheet of material, like the material you have. It's several plies of prepreg. This is a single layer of thermoplastic prepreg. It's a carbon fabric with thermoplastic on both sides. And several layers, like 3 layers for example, are stacked and then pressed together to make a nice laminate. So we're heating a line, a straight line, and it's 2 meters in length, like 7 feet in length. You heat a straight line and then very quickly fold it over. And then you're finished. So you need a folding machine with hot elements, and you have to push a little bit on the tip to make it nice and smooth. And the cost is 50% of what we did before. And before we bought prepreg and we were laminating on a tool, we were autoclaving the product. And here you buy a sheet of material with added value and then very quickly make the shape. So it's about cost reduction. The quality of this folding is not so good. You can see in your little specimen, the fibers are all crumpled up. But for a trailing edge of a rudder, that is a secondary part, it can be acceptable. It's just an example of what you can do with thermoplastics.